I am very much sure that even though we are having the recorded version of the lecture available, none of the absent students must have approached you for the what we can say recorded version of the lecture for observing it. If this is the way in which students are looking at it, then even an angel can't help them. We hope that the advanced technology which is readily available, the fortunate nature of today's generation is that the advanced technology is now readily available. It is not that earlier advanced technology was not there. It was there in various ages, but it was not as readily available as it is today. So I once again appeal to all of you to make its best use. We'll continue the discussion based on signals and systems. This being the first week, we are not still specific to the exact point, but we had improved a lot that our deviation is less. So in general, what we can consider that there is a concept of signal, that is one variable which has got a particular value and that is mapped with respect to other variable which is usually time. So we are having concepts of voltage signal and current signal, but in that again we make use of voltage signal most of the times. So voltage signal is available to us. There are signal generators which may generate different types of signals. That is right now not a point of our interest. So such signal is then applied as an input to a system which may be an amplifier or a filter, which are two popular systems, and then it produces the output. In this subject particularly, we are trying to model the behavior of various such systems which are physically existing. Means taking a transistor, having some kind of arrangement with the transistor like an RC coupled amplifier or a DC amplifier, providing the input, getting the output, constructing a filter using RNC, having the circuit arrangement, getting the output. So what do? We apply input, we have a system, we obtain output. We try to now analyze. Means given system, we analyze. That is called analysis. Or we design something, for some properties we require, we build up that is called a synthesis. So analysis and synthesis are two reverse processes by which we either study a known system or design a new system. We can take a complete view of how the things do work based on the information which we have obtained in yesterday's lecture. That what we can say, that a system receives the input, based on the receipt of the input some physical parameters are altered of the system in a sense that the input is able to have its lasting effect in the system, and that is called as state of the system. So input right now makes an impression in the system. That is, when we connect an RC circuit, the capacitor gets charged. Charges get and remain accumulated across the plates. So that is the change, or to be more particular, a permanent change produced by the input which has come and gone. So that is called a state of the system. So effectively, if it is a requirement that a signals and system course should be taught in 1 hour, in that case what you will teach? So today we shall focus on a complete summary. This does not at all mean that entire course is covered. So I presume that you have understood, and even if you are not understood, you have broadly understood. That is the concept of voltage signal, that everybody has got a fair idea about what is voltage signal. Everybody has got a fair idea about a system, maybe amplifier, maybe filter. So I am very much sure that with respect to voltage, where we are having concept of common ground, which we usually do not refer anymore now, it is like this. So we apply a signal generator. It need not be all this, it is a generator, signal generator, which results into V in T, and I have connected a CRO. It may be a voltmeter, it may be a device which will capture data like a digital device, ADC, and further to a computer or CR. Means here I have got a meter, maybe in one or other form, and it is VOT. And this is what I say as a system, right? So this gets, with all other things assumed, I can say a system only like this, and I will not show any more things now. V in T and VOT. It need not be V always. If it is a moving coil voltmeter, then it may be theta on T, right? It need not be VO always. It can be, for some instances, theta naught, because the system includes the meter itself, right? So this we can say as some kind of indicator, we can say like that, where the output is to be only observed. Observation cannot be a purpose of any system. It is to be applied somewhere, but right now the purpose is observation. We want to observe for output. Otherwise, it can be a mic which generates something, and it can be amplifier, it can be a speaker. So this generator may come from mic, some processing system. So audio signal converted to voltage signal, its amplification, and speaker. So there are various ways. It can come from some thermocouple, like that. So V in T is what I can say. So as money is the, what we can say, mechanism with which all things are converted into monetary equivalent, so that it can be traded easily. Similarly, the role of voltage signal is like money. In the sense, you find in the systems, the input parameter gets converted into a voltage signal, it is processed, and then voltage parameter gets converted into an output signal. It may be audio mechanism, it may be video mechanism, it may be a process control in an atomized environment, and so on and so forth. So V in T is the input which comes from some physical arrangement. VOT is the output which goes for controlling some physical arrangement, and it is the middle block is the system. It is actually a physical arrangement of components. Usually when we think of electrical thing, it includes a resistor, capacitor, transistors, or operational amplifiers. That's all. Inductors are there, but not that way required. We can work well with the capacitors, resistor, capacitor, and amplifiers. When I talk of an amplifier, I should have both the things understood very clearly. That an ideal amplifier cannot exist, but at a block level inside it, it can exist. Means I should have an idea about the impossibility of an ideal amplifier. Means it would be smoothened ultimately. Instantaneous working is not possible. But merely because I know that, every time I should not use that knowledge so as to make all the things impossible. Are you getting me? We must have idea about it. That ideal is impossible. But if it is fairly good, I can say that for my application, it is as good as ideal. Instantaneous response is not possible. But if we look at CRO, the response of the electron beam is very fast as compared to moving coil voltmeter. So I can say that moving coil voltmeter is a very sluggish device, but CRO is substantially fast device, and for my practical purposes I can very well say to be instantaneously responding. Remember, I am not contradicting myself. Instantaneously responding systems are impossible. Means that there would be some delay, some kind of sluggishness, some kind of inertia, so that there would be an ultimate smoothening in the output. Every system will have by default an averaging mechanism. But if my input changes are slow enough so that the system sluggishness is immaterial. Are you getting me? Means, I can give a simple example. Whether the paper is tough or not tough is a question for whom? Who has fairly studied. For him that question matters. But a fellow who has not studied, for him that question doesn't matter. So, if we are not in a position to get any difference out of the comparison which we are going to make, unnecessarily wasting time in that is not justified. So we consider that instantaneously are not possible. But when I say that the limitation of the physical systems in not able to respond instantaneously results in the smoothening of the input while output is being produced. But if input is very much smooth itself, in that case, that is not so. Instantaneous responding inability is not a factor which I am going to consider. Therefore, at block level inside the system, I will use, for simplicity and convenience, the ideal multiplier blocks. So once those blocks are considered, my system is complete. Resistor, I get an attenuator by resistor arrangement. So it is also not instantaneously responding, but I can presume very well. Resistor, capacitor and multipliers. I am specifically using the word multiplier because when I said, one may contradict me. Yesterday only I had said that an amplifier cannot work in an ideal situation. It can't have a equation of VOT equal to phi into VIT. Whether you are designing multiplier. So we are specifically using the word multiplier, that it is an element which, even though I am knowing to be impossible, I am having it because its impossibility is not a issue about which I should worry. I hope that I had used all possible ways of explaining what I could. Right. So a system is nothing but interconnection of these components. Resistor, about which we know the property, capacitor, about which we know the property, and multipliers. That's all. Nothing remains when you are able to use these three elements in the way you want. So with that we can design any system. Then ultimately, what is a system now? The thing is very simple, that the output of any system in the world is nothing but the weighted average of previous inputs. Now when there is a question of average, if it is a discrete system, then you can compute average by mean, that is summation of wi xi, right, upon summation of wi. But if it is continuous, then the weighted mean gets changed to the concept of average area under the curve upon base width or average height of that curve, and that curve is because of multiplication of the input and the weight curve. We are having a continuous thing, means I have one signal like this. Up to this only I consider. Means to say that I have inputs like this. If I am having a discrete set, then I have given inputs. Each I will have one weight, and I will multiply weight into input. W1 x1, W2 x2, W3 x3, W4 x4, right? And to that I will divide by summation of W1 plus W2 plus W3 and so on. But if it is going to be a continuous thing, in that case there would be an input signal and there would be a weight curve, or I can say to be signal itself. So this may be the weight signal. Weights, individual weights of individual points now, but it's a continuous. So have you thought of the multiplying curve? See, it is very unfortunate that despite all kinds of techniques which are being implemented to simplify the otherwise complex subject, if you can now justify your non-attention to the remedy available to you of reviewing the things, it is unfair. So I expect everybody of you that they should try their level best to listen each and every word. Despite that, if they are unable to understand, then they should go for recording view. And despite that, if they are unable to understand, they should have a peer discussion. Despite that, if they are unable to understand, then they can come to me and talk. And despite all these things they are unable to understand, still they will pass. Because we are having a very user-friendly system. So then we multiply. And point to point we multiply these two curves and then prepare a curve which is multiplying of these two curves, and then find out area under that curve. And that is what we can say the weighted sum. Actually, there is one requirement that this area is also important. This area, if we take 1, if we take this area to be 1, in that case, taking this area to be 1 is equal to say that summation of all WA is 1. Like this. It's weight, or it need not be weighted average. It may be weighted sum. We can modify that the output of a system at any point of time is weighted sum of all previous inputs. When I say all previous, then it should go till minus infinity. But obviously, again, we should be practical that after some time that the weights are highly negligible, I can ignore them. So I just rephrase my word of average. There is no need of division now. So even if I say that every student is able to understand the theme of today's lecture, then their purpose of being here, then their purpose of having studied the subject signal system would be over. After the purpose of subject is over, what is to be done? that I leave to every individual. Output of a system is weighted sum of all previous inputs. When I say weighted sum, in discrete thing, I am having inputs, I have previous inputs. So even though discrete thing comes after continuous and in the second section, to have good understanding, discrete is somewhat advantageous, because in continuous there is a concept of integration, convolutional integral, that gets changed to convolutional sum in case of discrete. So whether discrete can represent the original one entirely or not, this is an issue, but we say that I am taking the samples so near to each other that I hardly lose anything. It's again a very common sense statement. In the first lecture only I had stated that what is the representation of the signal? The graph itself, because the graph shows all values which are available with infinite resolution, the graph says. But now for practical purposes I can say that I have got 1 minute input signal. Then if I take value at every millisecond, then that would be more than enough for me. So if, or we can have micro anyway, which is not to be implemented. So whether we say milli or micro or nano, it is not going to harm us in any way. Let us say microsecond. So if I take value of the signal at every microsecond, then that will act as a sample. It acts as a sample, and instead of xt, which is a continuous signal, xt is a continuous signal, I say xn, which is equal to x of nt, where t is a sampling interval and n goes from 0, 1, 2, 3 and so on. Is it clear? And xn is not digital, it is discrete. It can take any value. Means what you are doing? You are wiping off some part and putting only points. The curve you are going to convert into just bar chart like this, points. There is no restriction for this point. It can lie anywhere on this line. If you want to give it to computer, you have to digitize further. So continuous domain, when samples are taken, it becomes discrete domain, and when the samples are quantized, it becomes digital domain. Discrete domain is of no use because we can't do anything with them. Analog computers are not there with us. So discrete to digital is so obvious, and with good quality ADs available, the difference between discrete and digital is hardly negligible. So what we can say, that the signal xt gets converted into the sequence xn. Is it clear? The signal xt gets converted into a sequence xn, which is array of numbers, and further I say can be stored in digital form. So you can have an experiment on it. On MATLAB you can do, or in C program also you can do. So once we have got xn, the things become very much simple now. So that is available as a stream. Xn is available as a stream. It will go to the system and y will come out. Xn is available as an input sequence to the system. system will process on that and generate yn. So what the system will do with this? The output is what? The output is a weighted sum of all previous inputs, or to be more particular, we can include current and previous inputs, because in digital, in discrete, current input is available that you can use, so that this sequence number is important, the instant is not important. So in discrete you can say current and previous inputs. So the output of a system is weighted sum of current and previous inputs. So I can write yn as yn is equal to summation of hn x of n minus k, where k varies from 0, it may go to infinity, it may go to infinity also, but that is right now we will not consider. It goes up to m minus 1, where capital M is the limit. Means I am having a window of m samples from current till m minus 1. So I want everybody of you to understand this equation very appropriately. Yn is equal to, is it being observed there? Yn is equal to summation of hn x of n minus k, where k varies from 0 to m minus 1. We can again, we try our level best to make the thing simple. Not means formula sometimes unnecessarily confuses. Therefore, we make a small example. Yn is equal to summation k equal to 0 to 3, 0 to 3. H of n x of n minus k means what? I can write in separate term, because I am having a phobia about the symbols, so which we want to get rid of. So h of 0 x of n plus h of 1 x of n minus 1 plus h of 2 x of n minus 2 and plus h of 3 x of n minus 3. That is yn, and n varies, means current output sample is weighted sum of current and previous 3 samples, right? Where H0, H1, H2 and H3 are the weights, right? And a different system means different weights. M can be 3, M can be here, M is 4, up to 3 samples I consider, previous 3 samples. M can be 5, M can be 10, M can be 100, and even that, in that weights may vary. So there are almost infinite ways with which I can design the system. What is system then? System is the sequence Hn, right? And it's a finite sequence. It can be infinite also, but right now we don't go for that. So in digital or discrete thing, what is input? Is a sequence. What is system? Is also a sequence. And what is output? Is another sequence. So it is just number crunching. It's a game of numbers and nothing beyond that. So signals and systems, especially the second part, is game of numbers. Now I am seriously considering which part should be dealt first. Whether we should go for the second part in its entirety, that I am considering, and after my thinking and consideration is over, which would be definitely by tomorrow, we will start with either of them, because it is most easy. Discrete time signal processing has to be understood. Means we cannot have a person who has understood continuous thing and not understood discrete thing, but we can have reverse, because in continuous thing it requires more rigorous analysis, more rigorous brainstorming. Once our base may be becoming ready due to discrete, we may, but I am just thinking of pros and cons of both approaches, and I will adopt an approach. So this is quite clear and simple now. You can write a program for this. What is sequence? Array of numbers. What is system? Array of numbers. What is output? Array of numbers. You can plot them and like that. Now we can have cascading of systems. We can have parallel combination of systems. We can have adder. There is a concept of adder in digital thing. We can also think of a feedback. It's a new phenomenon now. It's a new phenomenon, and it's quite interesting. We had stated that I can have a system in which the output is dependent on current and all previous inputs, or the output is the weighted sum of current and all previous inputs. When I say all previous inputs, what will happen with this m minus 1? This will become infinite, and it will create problems. The problems are, as I proceed, the computation to be carried out for determining the output will increase, and there will be a situation where the processing time will be more than the sampling interval. It's actually real time also. Samples which are being provided, I can store them in the array and I can give. Also it can be captured online. Online capturing can be there. The captured array goes to the processing block and output comes. If it is an online process, and in that case the computation time required for computing one output sample is more than the intersample period, then my system will fail. And since it is infinite, after some time it is means compute the time required. We presume that samples before 0 are 0. Right now we presume that x of minus 1, x of minus 2 are 0. So y of 0 may be only h0 x0. But y of 1 is h0 x1 plus h1 x0, and so on. So as n grows, the computation size grows. So this is a major impediment, major bottleneck, major problem we can say. Then, is it now possible to have the effect of all previous inputs, but by having a restricted calculation set? Means if I make anything here less than infinity, this will not. If I make this upper limit anything less than infinity, then this defeats my purpose, that the output now cannot depend on current and all previous inputs. Then it becomes output depending upon current and few previous inputs. This is actually finite impulse response system. What is impulse response right now we don't know, but it is this is a very popular word. Finite impulse response system. What is that? We shall come to it at a suitable time. Then the question is simple now. How can we make dependence on all previous inputs in finite computations. I will give an example. Suppose if the question is simple. A task is assigned to you that have addition of first n numbers. I give. You perform addition. Then I say have addition of n plus 1 numbers. Then will you again start from first to n? No. So there is a concept of iteration. There is a concept of iteration. So in iteration, let us say that I have got a simple system. y0, yn is equal to k equal to 0 to infinity s of n. This is what I want. This is what I want. Then how can I construct this? Can I construct this by conventional means? You think, how can you write a suitable computer program to construct this? Think for a while, how can you construct this? Anybody who has got solution? No? You want just addition, that's all, of all samples. So what is y0? There is an array of numbers available, x0, x1, x2, x3 is either available or will be coming from a stream. x0 comes, what is y0? x0 itself. x1 comes, what is y1? x0 plus x1. x2 comes, what is y2? So can you have a shortcut to do this? What is that?
Just 1 upon 2.
X of n.
X of n.
X of n.
Plus 1 upon 2.
No, but what? So can you write, this is an infinite sum. Can you write this
Integration.
in a finite, not integration, this in finite terms, but it will have effect of same. Yn, what is y2? y2 is x0 plus x1 plus x2. What is y3? I think I write.
Y0 plus
I want to write in such a manner that everybody should understand the answer. So now I have y2 is equal to x0 plus x1 plus x2. I have write y3
Y2 plus x.
is equal to x0 plus x1 plus x2 plus x3. Can you compact this with y3?
Y2 plus
y3 as y2 plus x3. So now matrix generalize. So yn is what? xn or the way you like. Or xn plus yn minus 1. So this is a single small equation which has only got two sums, but still it has got infinite effect. So output depends on current input and previous outputs, which in turn depends on that input and previous outputs. Are you getting me? So current output depends on current input and previous output. Previous output depends on that input and previous output. So it's a iteration and it goes back. Here I have taken 1. It can be any. Means now we can have a system in which here the weights are 1. Right now I have chosen, but they can be different. So what I can say that I can have a system which will depend on current and previous inputs and some past. It can't depend on current output because it would be then not instant responding. If it would be then infinite looping. Unless the output is produced, it can depend on itself. So a system is depending, the current output depends on current and previous input samples and some past output samples. So even if it depends on a single past output samples, it becomes, because that single past output sample takes into consideration those previous inputs which have gone beyond the window of considering them at the input level only. So what I can have, now I can have a system in which I give it as yn is equal to summation of k equal to 0 till m minus 1. Here instead of h I give b of k x of n minus k plus summation of, you can use z or you can use k only, 1 to maybe say n, a of k, y of n minus k. It is like this, and at least when I have one non-zero AK, then my system is infinite impulse response, IIR. Its output depends on all previous inputs in either direct or in indirect way. So if all AKs are 0, then my system is finite impulse response system, in which it depends on the inputs but only up to a window, and in that window previous input only it considers. But when I have at least one non-zero AK, I achieve the same effect. I achieve the same effect without infinitely computing the things. Means this can be a finite term representation of this infinite term equation. These two are equivalent. These two are equivalent, wherein this up to m I can consider m minus 1, but beyond that, that is taken care in this. So this equation and this equation is having infinite dependency on all previous input, that is infinite dependency and infinite terms, whereas this equation has got finite terms, still infinite dependency due to iterative nature. Is it clear? So you can write an easy program, you can have some input, you can design some system. So, and in that the thing is that here in discrete thing, system is nothing different than sequence input. Input is a sequence. In analog or continuous nature, input is a signal, system is arrangement of physical components, and output is again a signal. Whereas when we discretize, input is a sequence, system is also a sequence, and output is again a sequence. So it is just playing with the numbers, and I hope that you very much like playing with the numbers. I hope that it was a very much rigorous discussion, and we take a break for the lunch. But again, you are supposed to call me.